Hi everyone. Okay, so this lesson is on applying exponent rules to area and volume. So our learning goal is to apply the exponent rules that we've learned to find expressions to represent the area of rectangles and volume of rectangular prisms. So recall that the formula for the area of a rectangle is area equals length times width. So it doesn't matter which one's which, but if you wanted to find the area of a rectangle, you multiply length and width. And the formula for the volume of a rectangular prism is volume equals length times width times height. So we've got volume is length times width times height for a rectangular prism. And we've got area being length times width for just a rectangle. So keeping those formulas in mind, our first example says determine an expression for the area, where this is a square we can see because both sides are the same length, which means all four sides are the same length. But if we use the area as the length times the width, we would get area is, so if that length is x, our width is also x. So here's where the exponent rules come in. We can simplify this because we're multiplying powers with the same base, and x times x is x to the power of 2. So the area of this shape is x squared. And the exponent 2, often the short form for it, we say x squared, and we can connect that to this shape here, which is a square, where both sides are the same length. So our next one is a rectangle. We're determining the expression for the area. So again, we're going to use our formula. Area is length times width. We know the length. We know the width. So we can substitute. So now we're multiplying terms together. So we have to remember that you multiply the coefficients together. The coefficients together, 5 and the 3. And then we multiply the variable parts together, x and x. So our area is 15x squared. Okay, and if you can think of x as being like a little length here, we could divide this into 5 equal parts that are x, and then 3 equal parts this way, and you can see there'd be 15 squares there, 15x squareds. This one, we have a rectangle again, and we're finding an expression for the area. So we've got our length. Doesn't matter which one's length and which one's width. Lots of people like the longer one to be called the length, but it doesn't matter because you're multiplying. So our length we're saying is 2y times our width, which is 9x. So again, we're multiplying the coefficients together. 2 times 9 is 18. And y times x, well, they don't have the same base, so we can't use an exponent rule here. We can just write our two variables, and usually you write them in alphabetical order. So instead of writing yx, you would write xy. That's just a convention. It wouldn't matter if you wrote 18yx, it would still be correct. All right, so we've done area here. Our next question is determining an expression for the volume. And we're still using rectangular prisms here. So for volume, to get the volume, you multiply length by width by height. So I like to label them on, especially if there's 3 of them, to make sure I don't accidentally use one twice and leave one out. So here's my length, my width, and my height, and they're all the same, which means this is a cube. And I've got my length being x, my width being x, and my height being x, so I'm substituting into the formula. And here's where the exponent rules come in. X times x times x, keep the base, same, add the exponents, there's those invisible ones there, so I get x to the power of 3. A cube has that unique quality that all of its sides are the same, so if I wanted, I could also say the volume of a cube is the length of the side to the power of 3, or cubed, this power of 3 exponent. You often say cubed when you see an exponent of 3, similar to saying squared when you see an exponent of 2, and you can see that for squared we have a square shape, and for cube we have a cube shape, and that's why those short forms came to be. So here, if I was using this formula because it happens to be a cube instead of this formula, length times width times height, the side length is x, so I'm substituting with brackets, cubed, which is just x cubed. So there's two ways I could look at that one, and that's because it has a special property that it's a cube. Okay, so the next one is a rectangular prism. So I know to get the volume, I'm going to do length times width times height, label them. So here's my length, my width, and my height. Now I'm doing substituting. So replacing L in the formula or length with 8x, width in the formula with 5x, and height in the formula with just x. And now to simplify, I use my exponent rules and what I know about multiplying. So I multiply the coefficients. Remember, there's an invisible 1 there, so 8 times 5 times 1 is 40. X times x times x, so I keep the base x and add these exponents. They're all ones, so 40x cubed. 40x cubed. And for C, similar. If you wanted, you could pause and try it and then check your solution. So we're going to do volume equals length times width times height. Here's my length, my width, and my height. Substitute. Remember to use brackets when you substitute. And brackets, beside brackets mean multiply. So now you're going to multiply 3 times 8 times 12. So 3 times 8 times 12, multiplying the coefficients, gives me 288. And then y times y times y is y to the power of 3. Keep the base and add the exponents. And our last example here, we want to determine the volume again. So length times width times height. I'll call this my length, this my width, and this my height. Substitute using brackets. Multiply the coefficients, so 11 times 2 times 5 is 110. X times x times x is x cubed, but that's still being multiplied by y. So an expression that can represent the volume of this is 110 x cubed y. All right. So going on to the next page, the next question asks, what is a simplified expression for the volume of the cube? So cube is a big clue here. It means all the sides are the same length. So the length is 5x, also the width is, and also the height is. And I'm going to show this in two different ways again because it's a cube. So first, we could always use length times width times height. And they're all the same. And then we're multiplying those terms together by multiplying 5 times 5 times 5, which is 125. And then x times x times x, keep the base and add the exponents. So you get 125x cubed. But because it's a cube, you could also use the formula, the volume of a cube is whatever the length of the side is cubed to the power of 3. So if I did it that way, I would replace the side in brackets with a 5x cubed. And then I know that I apply this power to both the 5 and the x. So 5 to the power of 3, I can do that on my calculator. 5 to the power of 3 is 125. X to the power of 3 I write as x cubed. So again, I got the same answer, 2 different ways. And I can use this formula of side cubed for a cube. All right, the next one. This time it tells you the area of the rectangle is 32x squared and asks you what the width is. So I'm going to show 2 ways to do this one as well. So it gives me the area and it gives me the length and it asks me what's the width. So I'm going to start off doing area equals length times width. So I know the area is 32x squared. I know the length is 8x, and I'm going to represent the width as some unknown box. I don't know what it has to be. So I have to ask myself, what do I have to multiply 8x by to get 32x squared? So I could think, all right, 32 divided by 8 is 4, so there must be a 4 in the box for the width. And x times x is what gives you the x squared. Okay, so that way of thinking is fine. So then you write therefore the width. So the 3 little dots here mean therefore, instead of writing out the word therefore. Width equals 4x. So there's one way to do it. So that's maybe using like a logic approach. And then also, if we know area is length times width, then we know that we could make the formula width is going to be the area divided by the length. If area is length times width, then width is going to be the area divided by the length. So we can fill in the area, which is 32x squared, fill in the length, which is 8x, and then use our rule for dividing. So we divide the coefficients. 32 divided by 8 is 4, and then x squared divided by x. So we keep the base x and subtract the exponents. 2 minus 1 is 1. So I showed it in 2 different ways. One may connect more with you than another. Okay? Either way is fine as long as you can explain your thinking. So the next one, the area of the square is 49x squared. What is the length of each side? So we know the sides are the same because it's a square. And we know the area is length times width. And we know the area is 49x squared. But what we do know is that the length and width have to be the same. They have to be the same because it's a square. Okay? So I know they both are going to end in x, but in order to figure out what number is going in front of each x, because it has to be the same number, I want to think of square root. So square root of 49, remember that button on your calculator. So the square root of 49 is 7, and that means 7 times 7 is 49. Okay, since it's a square, the length and width have to be the same. So the length of each side, so I'm going to use that therefore again. Therefore, each side it has a length, represented by, so each side has a length represented by 7x. Okay, so in other words, this is 7x and this is 7x. And when you multiply them, you get the area 49x squared. So that was a bit of a thinker there. Next one, we're given the volume. So the volume of a rectangular prism is 420x cubed. What is the height? So we've got the length and we've got the width, but we don't know what the height is. So this is our height, but we don't know what it is. So again, there's two ways to think of it. One is to write out the formula that we were given and then replace volume with 420x cubed, length with 12x in brackets, width with 7x, and then a box with the unknown in it, which is going to end up being our height. So we can multiply these ones together because we've got them. And we're just multiplying the length and width right now. And when we do that, we get 84x squared. So that's the length and width multiplied together. But we're still multiplying that by some unknown that we can figure out. So what multiplies by 84 to get 420? So we would do 420 divided by 84 on the side here or on our calculator. 420 divided by 84 is 5. So we know the height's going to have a coefficient of 5. And we want to get to x cubed and we have x squared. So we need another x there. So 5x. So therefore, the height is 5x. So there's one way to do it. The other way to do it is using a formula. So if volume is length times width times height, then the height is going to be the volume divided by the length times the width, or the volume divided by the area of the base, which is length times width. Okay, and remember there's the invisible brackets here, so we would substitute in volume as 420x cubed, and length as 12x, and width as 7x. And then we have to do the denominator first, simplify the denominator because of those invisible brackets. 12 times 7 is 84. X times x is x squared. And then we do our dividing using exponent rules. So 420 divided by 84 is 5. X cubed divided by x squared is x to the 1 because 3 minus 2 is 1. So therefore height is 5x. And you could check your answer by multiplying. So you could see if 5 times 12 times 7 gave you 420, and x times x times x gives you x cubed. Okay? So there's two ways to get that one or think about that one. So the volume of the square-based prism is 108 a to the 8th, b to the 4th. So again, we're given the volume this time. Determine an expression for the height of the prism. So we can use one of our two methods here. I'm going to use the formula one. So I know height is volume divided by length times width. They both happen to be the same because it's a square base. So our height is 108 a to the 8th, b to the 4th, divided by 3a squared b for the length, as well as 3a squared b for the width. So again, I'm going to simplify the denominator first. 3 times 3 is 9. A squared times a squared is a to the 4th. Keep the base and add the exponents. B times b is b to the power of 2. And now I use my exponent rules to divide. So 108 divided by 9. Do that on your calculator. 108 divided by 9 is 12. So there's the coefficient of the height. A to the 8th divided by a to the 4th is a to the 4 because you subtract the exponents and keep the base. And b to the 4th divided by b squared is b to the power of 2. So that means our height would be 12a to the 4th b squared. And you can say therefore height is represented by 12a to the 4th b squared. And again, you could check your answer by multiplying. This times this times this needs to give you 108 a to the 8th b to the 4th. Okay, so that is the end of the lesson. At this time, you should stop the video. Make sure you rewind if you missed something. You can always go back and then try the practice questions.